Today we are solving the problem on event scheduling or time advanced algorithm, or it is also called as one channel queuing problem. Okay, and the question is, prepare a simulation table for one channel queuing system using event scheduling or time advanced algorithm with stopping time 60 and inter-arrival time and service times are given below. Here inter-arrival time is given here and service time is given here. We know that the first value of inter-arrival time should be always considered as 0. So 0 here. Now count the number of inter-arrival time and service time. Check whether they are equal. 1, 2, 3, 4, 5, 6, 7, 8. These are 8. 1, 2, 3, 4, 5, 6, 7, 8. Yes, they are equal. So we are not excluding any term from the inter-arrival time. Okay. Now moving to the solution. Now the first step here is to compute departure time. Okay. Inter-arrival time is given in the question and service time also given in the question. The first value of inter-arrival time here considered as 0. So putting dash there and copy down the other values from the question. Okay, and arrival time can be calculated as, just put the first value same, that is dash, that means 0. So putting 0 there and now add 0 plus 1 and put here, that is 1. 1 plus 1, that is 2. 2 plus 6, that is 8. 8 plus 3, that is 11. 11 plus 7, that is 18. 18 plus 5, that is 23. 23 plus 2, that is 25. Okay. Now for the departure time, use this formula. Okay, remember that this formula is for the customer who are in the queue. Okay, and this formula is customers which are not in the queue. Okay. Now for the first customer arrives at time 0, so there is no one in the queue, so we are using this formula for calculating departure time, that is arrival time plus service time. The arrival time plus service time, that is 0 plus 4, that is 4. Okay. Second customer arrives at 1, but the departure time of first customer is 4, so the second customer enter into the queue, so we are using this formula, that is the first formula to calculate the departure time, that is service time for current customer is 2, that is 2 plus departure time of previous, that is 4, that is 2 plus 6 is equals to, 2 plus 4 is equals to 6. Okay. Now for the third customer arrival time is 2 and the departure time for the second customer is 6. It will enter into the queue, so we are using the formula 1 to calculate departure time. Okay, that is service time of current customer plus departure time of previous, that is service time for third customer is 5 plus departure time for previous customer is 6. So 5 plus 6 is 11. Okay, calculate for the other values also, you will get the results. Okay. Now the second step is simulation table. Now we need this much columns. Okay. Now first we will write the values of clock. Okay. Just go to the table 1 and consider the values of arrival time and departure time. Write them in a order so that you will get the clock values, that is 0 first, and you will get these values. Okay, from 0 to 28. Okay, now go take the 0 and go to the first table and check where 0 shows. Okay, it is the arrival time for the first customer, so we are writing A1 here. Okay, now take 1 go to the first table and check where 1 lies, and it shows arrival time of a second customer. Okay, so write A2 here. Now take 2 and go to the first table and check where 2 shows for the third customer arrival time. Okay. Third customer arrival, so A3. Now for 4 here, it is a departure for a first customer, so writing D1. Okay, continue for the other values also. Now this column acts like a queue. How many customers enters into queue, that much we need to write here. Okay, and this is for the service. If the service is allowed for the customers, then you need to consider here. Now the first customer arrives at clock 0, so he will not enter into the queue, but the service is allowed for him, so we are writing 0 here and 1 here, and the future events will be, that is arrival of a second customer. Okay, that is at 1, and now for the departure, that is at 4, and end point will be 60, which is given in the question. Okay, now the first value of BZ and max Q is always considered as 0. Okay, solving the thing, we will understand this diagram. That is, if the current customer is in running stage and the service is allowed for it, then the arrival of that value should be considered as 1, and if there is any middle arrival occurs while the process is in running, then for that customer we need to consider departure time also as 1 here in this column. Okay, okay, and the middle arrival customer arrival time should be also considered as 1. Okay, now we will solve here. You can understand with that diagram. Okay, now second arrives occur, so just go to this diagram. The current customer is A1 and it is in running stage because the departure time is at 4, so this one the second customer is arrived before the departure event, so we are considering a departure value for the current customer is also 1. Okay, and customer arrives in the middle, so the value is considered as 1, so 1 here. Okay, and now for the first customer is done. Now consider second customer because it is not departure at. Now we consider the current customer as A2. Now check whether there is any middle arrives occur. Yes, there is middle arrive occur for the, that is A3, so the departure value of A2 should be also considered as 1 here, and the middle arrival should be also considered as 1, so writing 1 1 there. Okay, now second customer is over. Now go to the third one and the departure is here for the third, and check whether there is arrives in the middle. Yes, there arrive occurs, so putting 1 there, and for departure value of A3 is also considered as 1 here. Okay, now A3 is completed. Now A4, here is the departure, and check whether arrives occur. Yes, arrives occur, that is A5, which is middle. Okay, so 1 here already written for the middle value, and for the departure value for A4 should be also considered as 1, so writing 1 here. Okay, now A4 is completed. Check for A5, there is no middle arrives occur, so we are putting D5 as 0. Okay, now A5 is also completed. Now A6. Now A6, as A6 goes, the service is given to that. So putting 1 here, and the departure time is here. There is no middle arrives, so 0. Okay. Now if now A6 is completed. Now consider for A7 now, and the departure for A7 is here. Now we are writing 1 because for A7, as the A7 enters, the service is provided for it, so we are writing 1 here. And there is middle array occur for the A7, that is A8, so we are writing departure value of A7 as 1, and the middle arrival also written as 1, and the departure for A8 for is 0 because there is no arrive occurs in the A. Okay, now we will fill the value of Q. Okay, for the as first customer arrives, the departure time is here, and there is no one in the queue, so 0 here, and the middle arrives occur before departuring the first one, then the value, this second customer enters into the queue, so the value here is 1. Now the third customer is also entering into the queue before departuring 1, so the queue value should be 2. Now next, now this departure occurs for the first customer, so we are excluding this. As the departure for our first customer occurs, the service is given to the second customer, so this will be in running, so we need to consider it from here to here, that is for departure to. Now this is queue, this will enter into the service, so there is only one customer in the queue, that is A3, so 1 here. Okay, now now departure for a second customer is also occurring here for the next value, so we are excluding second also. Now as the departure occur for the second customer, the arrival customer not in the queue, now it will move to the service, so there is no one in the queue, so we are putting 0 here. Okay, if the departure occurs, just minus 1 this. Okay, if the departure value here, that is 2, if the departure occurring, so we are just putting minus 1 and put value here. Okay, if arrive occur, then do plus 1. Okay, that is simple. Okay, then the value will be 0 1 1 here, 0 0 0 0 1 0 0. Okay, follow the steps. Okay, you will get these results. Okay, now for the future event, let's just write the future events. Okay, here, and you will get these results. Okay, now busy. Okay, now before solving the busy, we will understand max queue, which means the maximum number of customers in the queue. Okay, that initially the queue is 0, so 0 and 1, now the 2, then that will be the max. There is no 3 value, so write 2 in the all the rows. Okay, now busy, which means how many minutes the server is busy. Okay, we need to calculate that. Okay, now for the second customer, the server is busy from 0 to 1, so the value here is 1. Now for the third arrival, the server is busy from clock 0 to 2, so the value is 2 here. Now for the fourth, okay, that is for departure, the server is busy from 0 to 4, so 4 here. Now for the departure for second customer, the server is busy from 0 to 6. So we are writing 6 here. Here this is for 8 here, and now it is 11. Next 15. Now 16, and now you can observe the value of BZ and the clocks are same until here, because as A1 arrives, the departure is here at 0 to 4. There is arrival here, that is there are 2 customers in the queue, so we are writing same here. The clock values are same. And next, for the second customer, there is still A3 in the queue, so we are writing the same clock values. And for A3, here the departure is here, there is A4 in the queue, so we are writing same. Now for A4, the A5 in the queue. Now A5 is departure, there is no one in the queue, so we are writing this much only. Now there are no one in the queue. The departure of A5 is also done. Okay, so the server is idle for 2 seconds, that is from 16 to 18. Okay, the server is idle for 2 minutes, so we need to subtract this value with the 2. So then you write the value here, that is 16, that is -2. Check whether there is arrival occurs from A6 to here the departure occurs. There is no arrival, so we are -2 only, so the value is 21. And for the next, and you will get these results. Okay, please follow the steps carefully, and the notes are available in my blog, so please visit my blog. Thanks for watching.